Okay, today we will be beginning our study of trigonometry, and this will continue throughout the remainder of the semester. So we'll be working with trig from now on, and we're going to specifically start with the unit circle. And for those of you that have had pre-calculus before or some higher level math, you may have encountered the unit circle. You may not have a pleasant experience with it, but we're going to try to make it as pleasant as possible, because the one thing I want you to understand is that the unit circle is a tool. It's not the end product. It's not the thing that we're trying to accomplish. We're trying to accomplish learning trigonometry, and we're going to do that through the unit circle. Okay, so what is the unit circle? The unit circle is simply a circle that's centered at the origin, and it has a radius of 1. And so the equation for the unit circle is x squared plus y squared equals 1. And that's simply the unit circle. So if we think about the unit circle and we think about some geometry, we know that the length around the circle is its circumference. And the circumference formula is 2 pi times the radius. So if we're talking about a unit circle, then the radius is 1, and therefore the circumference around the unit circle is 2 pi. So that's an important value that you're going to need to keep in mind, is that to go all the way around this circle, it's 2 pi radians. Okay, so one thing you may be asked to do is to show that a particular point is on the unit circle. So in order for it to be on the unit circle, you have to be able to plug it into this equation, which is the equation for the unit circle, and show that it's a true statement. So if it's a false statement, then it's not on the unit circle. So this is going to be my x, and this is going to be my y, and I'm going to plug those in to this equation. So I'm going to put in the place of x, I'm going to put in the square root of 3 over 3. And in the place of y, I'm going to put in the square root of 6 over 3. Okay, and so we're going to check to see if it does equal 1. Here, if I square the square root, I get rid of that, so those are going to cancel. If I square my 3, I'm going to have a 9. Here, if I square the square root of 6, the square and the square root cancel, I'm left with 6. If I square the 3, I get a 9. So 3 ninths plus 6 ninths is going to be 9 ninths, or 1. And therefore it does equal 1, and therefore I have shown that it's on the unit circle. Okay, so when we talk about what's called terminal points are going to be points along the unit circle. And it's important to understand that when you have a t value that's positive, we're going to be going counterclockwise. Okay, so this is always our starting point. This is where we start. And so if we have a positive t value, then we're going counterclockwise. If we have a negative t value, we're going to still start here at this starting point, but we're going to go clockwise in order to get to our terminal point. Okay, so just to kind of summarize, the point that we end up at is the terminal point. So we have a circumference of 2 pi. So to go all the way from this starting point all the way around, then we've gone 2 pi. And so this point here is known as 0, but it's also known as 2 pi on our unit circle. So if we haven't moved at all, it's 0. If we've made a complete revolution, it's 2 pi. It could also be 4 pi, because if we went around again, then it would be 4 pi, go around again would be 6 pi, and so forth. So I want to look at some of these other places that are, these other terminal points on the unit circle that are important to us. And one of those is halfway around the circle. So if one whole revolution of the circle is 2 pi, then 2 pi, if I cut that in half, then I'm just going to be at pi. So the coordinates over here, halfway around this circle, is pi. The terminal point is pi. The coordinates of this point, since this is the origin 0, 0, the coordinates of this would be -1, 0. So I would go -1 and then 0 for that. This one, the coordinates would be 1 and 0. Okay, so halfway around the circle is pi. So if I only go a fourth of the way around the circle, then 2 pi divided by 4 is going to be pi over 2. So this one is pi over 2, and the coordinates of this point would be 0, 1. And the last one that I want to talk about on this slide is if I go 3/4 of the way around, that's going to put me down here. And so 3/4 of 2 pi is going to be 3 pi over 2. And the coordinates of that location is going to be 0, -1. Okay, and so you can see what we're talking about is when we say t equals pi over 2, we're actually starting here and traveling to the point here, which is the pi over 2, and that's where we're going to end up. And you can kind of see that how that's represented. So 2 pi, we go all the way around. 3 pi over 2, we go 3/4 of the way around, and so forth. Okay, so for each one of these, what we want to do is to identify the terminal point on the unit circle. So I'm going to give you a minute to see if you can determine where you think these points would be and give the coordinates for that, and then we'll talk about it. Okay, on the first one, we have a positive t value, which means we're going to go counterclockwise. So I'm going to start here, and I'm going to go around. This would be pi, 2 pi, and then 3 pi is going to take me over here. So 3 pi, the location for it is going to be here, and the coordinates will be -1, 0. This one we have a negative value, so that means we're going to be moving clockwise, and I'm going to move pi units. So pi units is halfway around the circle, but if I'm going in the negative direction, then I'm going to go clockwise. So again, I start here at my starting point, and I go clockwise pi units. So actually pi and negative pi, we end up at the same place. So the coordinates for negative pi are going to be -1, 0. It's also the same as 3 pi. So the terminal points are not unique because there are multiple t values that are going to give us the same terminal points. Here, negative pi over 2, positive pi over 2 would take us up to the top here. So if I'm going to do the negative direction, I'm still going to start at the same place, and I'm going to go to the bottom. So negative pi over 2 would be down here, and the coordinates of that are going to be 0, -1. Okay, so these are just a couple diagrams that are a little bit nicer than what I can show you. So 3 pi, you're going all the way around and then halfway around again. And then for negative pi, you can see that you're coming in the negative direction around. And then for negative pi over 2, we're going to be down here for that one. Okay, so adding to this, because we've so far we've looked at basically the quadrant changes for our unit circle. Now we're going to look at the point, the t equals pi over 4. So for pi over 4, that's a fourth of the way around this unit circle here, or so we're going to be here for pi over 4. Pi over 4 actually falls on this line y equals x, which splits the quadrants in half. And it also splits in half the third quadrant down here. And that's going to be important as we develop this unit circle. So here we have pi over 4, and we want to find the coordinates of this point. So we know that it's on the unit circle, so it's going to be x squared plus y squared equals 1. We also know that x and y are equal to each other. So what I'm going to do is I'm going to replace y with x, but since they're equal to each other, so I get 2x squared equals 1, divide both sides by 2, and then I'm going to take this square root. So x is going to be plus or minus, the square root of 1 is 1, and the square root of 2. When we rationalize this, we'll multiply both by the top and the bottom by the square root of 2. So I get plus or minus the square root of 2 over 2. So that tells me my x and my y are equal to each other. So the coordinates for this point here are actually the square root of 2 over 2 and the square root of 2 over 2. Since x and y are equal, then we get the same value there. and the value is that square root of 2 over 2. If I were to come down here in the third quadrant, it's actually the same values, but because of this plus or minus that we get here, and in the third quadrant, we know that the coordinates of everything in the third quadrant are both negative, so we end up with negative square root of 2 over 2 and negative square root of 2 over 2. So this one is a positive pi over 4, and so this will be 1/4 of the way to pi. So this will be 1/4, this will be 2/4. Over here is going to be 3/4. So this will be 4/4, which is pi. And so this is going to be 5/4 here. Okay. And we can go ahead and develop the rest of the unit circle from this. So this one we said was 3 pi over 4. So down here, we're going to go 5 pi over 4. This would be 6 pi over 4, which we know would reduce to 3 halves. And this is going to be 7 pi over 4. The coordinates of all these pi over 4s are going to be the square root of 2 over 2 and the square root of 2 over 2. This one in the second quadrant, we know in the second quadrant it's negative, positive. So it's going to be negative, positive for that. Down here, again, it'll be the square root of 2 over 2, square root of 2 over 2. And this one's going to be positive, negative. So positive and negative. So you can see that all of our pi over 4s, whether it's a pi over 4, a 3 pi over 4, a 5 pi over 4, or a 7 pi over 4, they all have the same coordinates. It's just the signs are different. In the first quadrant, it's a positive and a positive. Second quadrant is negative, positive. Third quadrant is negative, negative. And fourth quadrant is positive, negative. Okay, there is kind of a quick way to do this. So we've talked about the pi over 4s. I'm not going to go through the whole thing for the pi over 3s and the pi over 6s, but those would be the other two that we need to be familiar with. So one quick way to fill out a unit circle is if you start here and you go 1, 2, 3, 1, 2, 3. Okay, each of these we're going to divide by 2. And we're going to take the square root of the numerators. Okay, so the square root of 1 is 1, and we'll leave this one as it is. The next one is exactly what we said we just found for the pi over 4s. And then here we're going to have the square root of 3 over 2 and 1/2. So this is going to be my pi over 4, which is equivalent to a 45-degree angle. This is going to be my 30-degree angle, which is a pi over 6. And this is going to be my 60-degree angle, which is a pi over 3. Okay, so we can transfer all of these. Once you know these three, then you can pretty much transfer them to all the other quadrants because it's just going to be these same three values, but with different signs. So in this quadrant here, as we said, it'll be negative, positive. This one's going to be negative, negative. And this one's going to be positive, negative. So, so what I like to do is the pi over 4s are always the ones that are going to divide the quadrants. So as we said, this one, we already went through the pi over 4, so I'm not going to go back through that. This will be 3 pi over 4. This one is going to be 5 pi over 4. And this one is going to be 7 pi over 4. Okay, with the pi over 6s, that's a sixth of the way over here to the to pi. So I'm going to just count. This is going to be 1/6, 2/6. If you reduce 2/6, you get 1/3. And so this is the 1/3 or the 2/6. 3/6 is going to be 1/2, and that's my pi over 2. Okay, 4/6, if I have 4/6, 4/6 is going to reduce to 2/3. So I'm going to have 2 pi over 3. This is going to be 5/6. 5/6 won't reduce. So this is going to be 5 pi over 6. 6/6 is just pi. 7/6 won't reduce. 8/6 reduces to 4/3. 9/6 reduces to 3 pi over 2. 10/6 reduces to 5 pi over 3. 11/6 won't reduce. And then 12/6 reduces to 2 pi. Okay, so once we have those all the way around, we can go back and any of the pi over 6s, we're going to put in these coordinates for. We're going to have the square root of 3 over 2 and 1/2. Here we'll have square root of 3 over 2 and 1/2. And here we'll have the square root of 3 over 2 and 1/2. So this one is going to be a negative. Both of these will be negative, and the second one will be negative. Okay, for the pi over 3s, all the pi over 3s have the same coordinate here. So I'm going to have 1/2 and the square root of 3 over 2. Here I'm going to have 1/2 and the square root of 3 over 2. 1/2 and the square root of 3 over 2. So again, this one will be a negative. Both of these will be negatives. And then the second one will be a negative here. And then we already had talked about the pi over 4s. They're all going to be the same as what we just went through on the previous slide. So make sure we get the signs. So first one negative, both negative, second one negative. And then we, of course, can fill in these quadrants. The quadrant changes. This would be 1, 0, 0, 1, negative 1, 0, and then this would be 0, negative 1. If you want to go ahead and do the degrees, you can. This one would be 90 degrees. And then if we go 30 degrees more than that, we're going to be at 120. This one would be 135 and 150. This one's 180, 210, 225, 240, 270. Then we're going to be at 300, 315, and 330, and finally 360. Okay, so I'm not so concerned about the degrees right now. We'll get more into the degrees in chapter 6. So chapter 5, we're mostly going to be working with radians. So I really wanted to look at all of the pi over 4s, pi over 3s, pi over 6s, and so forth. Okay, so there is a blank one here that you can print off and practice with. If we were in a face-to-face class, I would be giving you a quiz on the unit circle. My recommendation would be that you simply print off a copy of the unit circle that's completed and have that as you're doing your work in this chapter. Okay, so this one is a completed one. This one may be a good one for you to print off if you would like that. Remember, the PowerPoints are accessible on Canvas and you can print it off from there. And you can actually look this up if you go to the link down at the bottom here to get a copy of it as well that way. So here's a little introductory video, a quick way to remember the unit circle. It's basically what I just went through, but if you would like to look at it and watch it again in maybe a different, slightly different perspective, that would be fine as well. Okay, so we talked about the terminal points, and if you remember basically these and then how they behave in each of the quadrants, then you don't technically have to memorize the entire unit circle. You definitely need to know the coordinates for each of these and the coordinates for each of the quadrant changes here at each of the quadrants. Okay, so what we want to do is, using your unit circle, we want to find the terminal point determined by each of these different um, numbers that we have here. So here we have a negative and we have a pi over 4. So if we think about this with the unit circle, what we have is, if we're going to look at this, I'm going to kind of sketch this out here. The negative tells me that I'm going to start here and I'm going to go clockwise. And I'm going to go clockwise pi over 4. So pi over 4 normally would take me a quarter of the way around. So it's going to take me here, but instead I'm going to go down here for that. So that puts me in the 4th quadrant. So what's important is the quadrant and the type angle I have. So the pi over 4s all have coordinates that are square root of 2 over 2 and square root of 2 over 2. Because this is in the 4th quadrant, it's that the first one is a positive and the second one is a negative. So this would be my terminal point for this. Okay, the next one here, if I look at this one, again, knowing your unit circle to some extent is helpful, because I know that 3 pi over 4 is here in the 2nd quadrant. So because of that, because of knowing it's in the 2nd quadrant, I know it's going to be a negative and then a positive. So the coordinates for the pi over 4s, as we've said before, are square root of 2 over 2 and square root of 2 over 2. And so I'm going to have negative and positive because it's in the 2nd quadrant. Okay, and so this is just kind of another visual of that. Okay, so the next one we've got is negative 5 pi over 6. So just going from your unit circle, your positive 5 pi over 6 is here. But because we're going negative, what I'm going to do is I'm actually going to go the same distance that I would have gone to here, but I'm going to go in the opposite direction. So I'm going to go clockwise. So negative 5 pi over 6 is down here. So it's in the 3rd quadrant. And so in the 3rd quadrant, I know that both are negative. This is a pi over 6 type angle. So for pi over 6 angles, it's the square root of 3 over 2 and 1/2 for the coordinates. So if it's in the 3rd quadrant and it's these coordinates, then my actual terminal point is negative square root of 3 over 2, negative 1/2. So yes, you do need to memorize the coordinates for your pi over 6, your pi over 3, and your pi over 4, and then be able to apply the signs for the quadrants. Okay, finding a reference number is really important, and the reference number is defined, it has the little line over the top, so if you see the line over the top, that indicates the reference number, and it's the shortest distance along the unit circle between the terminal point determined by t and the x-axis. Okay, so in other words, here's my x-axis, here's my, let's say this is my t, then what the reference angle is the shortest distance along the unit circle. So it's going to be this distance here between the terminal point and the x-axis. Okay, so you're always measuring it from the x-axis, basically. So like if it's in the 1st quadrant, then your reference number and your t are going to be one and the same. You really don't have to worry about it too much in the 1st quadrant. In the 2nd quadrant, the t is going to take me all the way around here, but that's not the shortest distance between the terminal point and the x-axis. The shortest distance is this part here, and therefore we're going to find this reference number by saying pi, which is this point we're at here, minus the t is going to take us to this point here, and that's going to be our reference number. If you're in the 3rd quadrant, you've already passed pi. So you've gone all the way over here. So you're going to take t and subtract pi from it, and that's going to give us this reference number in here. And if you happen to be working in degrees, just replace pi with 180 on these, and that would tell you how to find the reference angle. Okay, your reference to be number here is for the fourth quadrant, you're going to do 2 pi, take away all of this, and it's going to leave you with this. So in each case, your reference number is always measured from the x-axis, the shortest distance to get to that terminal point. Okay, so this is just kind of another visual of the same thing. Okay, so if we're looking at these, a lot of people try to oversimplify this and say, look at this and say the denominator is 6, therefore the reference number is pi over 6. And while that is true, I do want you to understand why that's true, because when you get to problems like this, it's easier if you've understood why pi over 6 is the reference number here. So looking at this one here, if I'm at 5 pi over 6, okay, 5 pi over 6 takes me all the way over here. So in the second quadrant, we always say pi minus the t. So that's going to be pi minus 5 pi over 6. So that leaves me with simply 1 minus 5/6 is going to be 1/6 pi, which is pi over 6. So pi over 6 is going to be my reference number for this one. And like we said, we could look at it and tell that pi over 6 would, but you really need to understand why that's the case. Okay, here 7 pi over 4. 7 pi over 4 takes us all the way around to the fourth quadrant. So my reference number is actually this part in between 2 pi and my terminal point here. So I'm going to do 2 pi minus 7 pi over 4. So 2 minus 7/4 is going to give me 1/4 pi, which is pi over 4. Okay, so on this one, we're going to be finding the reference number for negative 2 pi over 3. So on this one, it does take us over here to the third quadrant, but basically, because we're going in a negative direction, the rules are not really going to apply as far as what to subtract. So we really just need to think about this is pi, and this takes us to negative 2 pi over 3. So essentially the difference between pi and 2 pi over 3 is pi over 3, and that's going to give me my reference number. So it's a little bit harder to visualize when it's a negative angle like that, but just try to think about literally it's that distance between here at pi and here. So if I've come 2 pi over 3 this far, then that leaves me with pi over 3 for this part here, which would be my reference number. Okay, so like I said, it's a little harder to visualize this 5.8. So what I would suggest doing is, first of all, you've got to figure out which quadrant that is. So if we convert each one of these to a decimal, pi divided by 2 is 1.57, pi is 3.14, 3 pi over 2 is 4.71. What we see is that 5.8 is actually going to be here in the fourth quadrant. So in the fourth quadrant, we're going to take 2 pi, as we have here, and subtract the 5.8 from it, and we're going to get 0.48, and that's going to be my reference number for this particular problem. Okay, so we're going to use these reference numbers to determine our terminal points. So I've listed a couple steps here. First thing is to determine your reference number. Second, find the terminal point associated with that reference number. So for the most part, it's going to be these that are going to be your terminal points. Determine the quadrant, and so we've got the signs assigned for each of the quadrant, and then use the sign for that particular quadrant to give your terminal point. Okay, so these are the ones that we just went through and found the reference numbers. So I want you to use the reference numbers that we found in order to find your terminal points. Okay, the first one here, 5 pi over 6, we're going to be over here in the second quadrant. And we know that our reference angle is pi over 6. So that tells me that it's going to be a square root of 3 over 2 and a 1/2. and in the second quadrant, it's negative, positive. So it's going to be negative, positive for our answers on that one. 7 pi over 4, our reference number is pi over 4 because like we just went through that. So what we're going to do here is we know that for pi over 4 is the square root of 2 over 2, square root of 2 over 2. We also know that 7 pi over 4 is down here in the fourth quadrant. So in the fourth quadrant, it's going to be positive, negative. So we're going to have positive, negative. And then finally here, negative 2 pi over 3, our reference number is pi over 3. So our coordinates are going to be 1/2 square root of 3 over 2. And this, if we go negative 2 pi over 3, that takes us over here into the third quadrant. We know that in the third quadrant, both coordinates are negative. So we're going to have negative, negative for our answer. Okay, so because we go around, we can keep going around the circle as many times as we want to. There are different t values that will have the same terminal point. So we're going to be looking at some that are beyond just the 2 pi. And I want to go through like the process for finding those. So what I want to do when you have one that when your fraction is greater than 2 and it's not showing up on the unit circle, then what I want to do is I want to actually divide this out by hand. So I'm going to do 6 into 29 doing long division. So 6 will go into 29 4 times. So 4 times 6 is 24. Okay, so 29 over 6 is the same as 4 and 5/6. So basically when I go to do this problem, what I've got to do is I've got to go around 4 and 5/6 times. So if you count with me, this is going to be 1 pi, then I'm going to be at 2 pi, 3 pi, 4 pi, and now I need to go 5/6. So 5/6 is actually going to take me over here. So this is the place that I'm going to be at. So 4 pi plus 5 pi over 6 is going to take me to this location, and that's the same as this 29 pi over 6. So our reference angle for this is going to be a pi over 6. So my coordinates are square root of 3 over 2 and 1/2. And since we're in the second quadrant is negative, positive. So that's going to be my coordinates. And obviously you don't have to put the plus sign. That's not necessary. I'm just kind of showing you that it does match up with this. Okay, so I have a couple for you to try here. So I would suggest pausing this and trying these and then watch and see how you should have done them. Okay, the first one here, this is more than 2, so I'm going to divide 6 into 13. It goes 2 times. So this is the same as 2 pi plus 1/6 pi, or plus pi over 6. So one complete revolution takes me to here, and another 1/6 is going to take me here. So my terminals, my reference number is pi over 6. My coordinates are going to be the square root of 3 over 2 and 1/2. And because it's the first quadrant, they're both positive, and so therefore that would be my answer. The next one here, if I'm at negative 17 pi over 3, I'll divide 3 into 17. That's going to go 5 times. 5 times 3 is 15 with 2 left over. So this is 5 pi plus 2 pi over 3. So 5 pi, I'm going to go, this is 1 pi, 2, 3, 4, 5. So 5 pi takes me here. And then another 2/3 pi is going to take me here. So I'm actually in the fourth quadrant, which is important because I know it's going to be a positive and a negative. My reference number is a pi over 3, so my coordinates are 1/2 square root of 3 over 2. And I'm going to apply the signs plus and minus, and I have my terminal point. Okay, last example, 4 will go into 39. It's going to go in 9 times, so that's going to give me 36 with 3 left over. So this is the same as 9 pi plus 3 pi over 4. So I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 pi is here. I'll go 3/4 of the way more. So this is another fourth quadrant. So another positive negative. We know that the reference number is a pi over 4. So we're going to have square root of 2 over 2 and the square root of 2 over 2, and that's going to be a positive and a negative. So here we have our reference, our terminal point. Okay, that takes us to the end of today's lesson, just getting oriented to the unit circle. So the main thing I want you to have accomplished out of today's lesson is understanding your reference angle, your reference numbers, your terminal points, and just the basic makeup of the unit circle. So let me know if I can help you in any way, and have a good day.